Two particles x and y having equal charges are accelerated through same potential difference. After acceleration, they enter a region with a uniform magnetic field and describe circular paths with radii r1 and r2. Determine the ratio of mass of particle x to the mass of particle y. When a charged particle is placed under a potential difference or in an electric field, the particle will get accelerated, right? And it will get kinetic energy. The kinetic energy of the particle will be equal to the electric work done by the field. Okay. So what is the kinetic energy? Kinetic energy is nothing but half m v square. And electric work done is q into v, where this is capital V, which is the potential difference. So we have half mv square is equal to q into v. So if we rearrange this, what we will get? V square is equal to 2qv by m, or we can say v is equal to square root of 2q capital V by m, where this is small v is the velocity of the charged particle. So this is the velocity of a charged particle placed in an electric field. Let this be equation 1. Now it is said that this particle enters a magnetic field, uniform magnetic field B, okay, and it starts executing a circular motion. It is executing a circular motion because, say, this Lorentz force is, when it enters the magnetic field, it experiences a Lorentz force, and to balance it, it executes a circular motion with a centripetal force Fc. And this Fc, centripetal force, and the Lorentz force both must be same. So that's why it is executing comfortably a circular motion. So Fc is equal to Fl. What is Fc? What is centripetal force for a particle executing circular motion? It is mv square by r. Okay. What is Fl? The Lorentz force for a charged particle under a magnetic field. It is qb v. Right. These both of them must be equal so that the particle is able to execute a circular motion. That means mv square by r must be equal to q into b into v. You can cancel v square and v, so it becomes mv by qb is equal to the radius of the path. Okay, the radius of the circle in which the charged particle is executing the circular motion is given by mv by qb. But what is v? V is the velocity. What is v? It is root 2 qv by m. Let's substitute that here. So radius is equal to what? Radius is equal to mv by qb, mv by qb, where v is, what is v? V is root 2 qv by m. Root 2 qv by m. This is from equation 1. This is equation 2. Substitute 1 in 2. So radius becomes m into, what is v? Root 2 qv by m by qb. Okay. Here you see, for the two bodies, let's rewrite this equation. It becomes like here q and q, this q get cancelled out. Okay, so his equation basically becomes r is equal to, how does it come? Square root of 2mv, square root of 2mv by, here one square root comes, okay, square root of qb. This is the expression for radius of the charged particle. Okay, now let's apply for the particle 1 and particle x and particle y. Okay, so r1 by r, they have mentioned rx ry, that is r1 by r2 must be equal to, here if you look at this equation, Both particles have the same potential difference, are under the same potential difference, are under the same magnetic field, are having the same charge, right? So R1 by R2 basically depends on root 2 mx by root 2 my, right? So R1 by R2 is equal to square root of mx by my. The question is to determine the mass, ratio of masses, right? So square root of mx by my gives r1 by r2, r1 by r2. So mx by my must be equal to r1 by r2 the whole square. So let's see the options we have. R1 by R2 the whole square. So determine the ratio of mass of particle X to the mass of particle Y. So it must be answer C. Thank you.